So this video is going to focus on the phase changes that we've been talking about. And again, we are going to be looking at specifically the plateaus. Okay, so this is where we have our delta H's. We are going to be looking at those specific calculations. So a phase change needs heat in order to change essentially the distance between particles. Okay, so either you're bringing the particles together or you're taking the particles apart. And for these phase changes, we are going to be doing things in moles again. So you will maybe have an additional calculation converting grams to moles, but besides that, that's the only way we're going to use the moles. We're not going to use it for anything else. So I'm going to give you just some definitions for these things. I would suggest you kind of pause the video, write it down, and then listen to me kind of talk about it instead of you writing it down as I'm speaking to it. So this is called heat of fusion, and the abbreviation is delta H fuse. It is the heat absorbed by 1 mole of a substance and melting from solid to liquid at a constant temperature. And constant temperature, again, you need to understand is delta T is equal to 0. So there is no change in temperature when we're at the plateaus. So this is an endothermic process, meaning I have to put energy in. So you're going to hear the term absorbed is going to be a word that you might see on worksheets and other things that give you an idea that it is an endothermic process. So heat of fusion is the exact opposite of heat of solidification. So this is heat loss when 1 mole of a liquid changes to a solid at a constant temperature. So it is delta H solid. It is an exothermic process. So that is why we write it as a negative, because what we're saying is we have to take heat out. So heat is lost, heat is removed, different words that you're going to hear here. So again, pause the video and write down this information because again, I'm not going to spend any more time on it. So please pause the video. Then we have heat of vaporization. So this is going to be up on top here. This is going to be going from liquid to gas and then gas to liquid. So it's another delta H. It is another delta H. So it's the heat absorbed by 1 mole of a substance and vaporizing a liquid to a gas at a constant temperature. Again, temperature is not changing at the delta H's. Delta H VAP is the abbreviation and it is endothermic. So please pause the video. And we have condensation, heat release. So again, that's another way you could put it. It is an exothermic process, 1 mole of a substance and condensing a gas to a liquid at a constant temperature. So COND is the abbreviation, and it is the exact opposite of heat of vaporization. So again, the number we have for heat of vaporization for water is 40.7 kilojoules per mole. So heat of condensation would be negative 40.7 kilojoules per mole. So again, those are the definitions that you need to know. So calculation-wise, these are pretty straightforward calculations, but I want to show you 2 examples so that you have them in your notes. So how much heat is absorbed when 4.5 moles of water changes from a solid to a liquid? And the heat of fusion is 6.01 kilojoules per mole. So a key word in this description is absorbed. And please note you're going from a solid to a liquid. So again, pause the video if you need to. So I'm going to show you 2 ways of doing these types of problems. So I could set it up as a proportion. So how many kilojoules is going to be required to change 4.5 moles of water if I know 6.01 kilojoules for every 1 mole of water? So I could set it up as a proportion. Kilojoules is to moles as kilojoules is to moles. If you do this, you're just multiplying these 2 numbers. So 4.5 times 6.01, and you get 27 kilojoules. And generally speaking, delta H is given in kilojoules. Now, the key to these calculations, is this a positive number or is it a negative number? So since I'm going from a solid to a liquid, I need to spread those particles out. So I have to put energy in. So when I say absorb, this must be a positive number. That must be a positive number. And you don't need to write down positive. You just need to write it normally. I'm just overemphasizing it. Another way you could do these calculations is by unit calculation. So I could take my 4.5 moles and take it as for every 6.01 kilojoules, it's going to be a mole. So if I actually multiply them in this fashion, the mole cancels the mole, and all I have to do is multiply these two numbers to get my 27 kilojoules. So if you would like to set up these calculations that way, I will perfectly accept it on a quiz or a test or on your worksheet. So if your brain can kind of realize that proportions is kind of doing the same thing here, I don't care how you do these calculations. All right, so the second problem, and then this will be the last problem on this video, how much heat is released when 2.5 grams of nitrogen, N2, is converted from a liquid to a solid? Now again, I like showing this one because this is a different substance than water, and it's given in grams, so you're going to have one additional step. But heat of fusion or heat of vaporization will always be given in the problem. So that's not going to be a number that you need to worry about, but you do need to pay attention to the fact that it says released. So again, pause the video if you need to. I'm going to take 2.5 grams of nitrogen and convert that to moles by doing my proportions. Again, some people were having problems with this on quizzes and tests before. This is nitrogen, N2. So it's not 14, it is 28, N2. There's two nitrogens there. So I cross multiply, so 2.5 divided by 28 is 0.089 moles of nitrogen. So that's just the additional step you have to do if you're in grams. Okay, that's all there is. Okay, so if this is heat of fusion, I'm going to take, okay, how many kilojoules are in 0.089 moles of the nitrogen? If I know it's 0.72 kilojoules for every 1 mole. Okay, so just like the previous problem, all I did was put my moles down here. You put the moles on top, it doesn't matter, as long as you are consistent. So this is multiplied, so X becomes 0.064 kilojoules, or you could write it as 64 joules, because again, the number is relatively normal in terms of size. Now, what you have to pay attention to is you're going from a liquid to a solid. Okay, what are you doing to those particles? You're bringing them close together. Well, in order to bring the particles closer together, you need to change essentially what the heat is doing. You're taking the heat out of the system. So because you're taking heat out, these are going to be negative values. Another way to realize that is I'm saying heat is released. Again, I don't want to over confuse you on this. I'm trying to hint at certain times what's taking place. But again, you're going from liquid to solid, so it must be a negative. So all you got to worry about is if it's in grams, convert it to moles first, use the heat, the delta H given in the problem, and then figure out if it's positive or negative. That's all you have to do with these problems.